Alright, new chapter. We are doing stuff with equations in this chapter. Before we can get to solving equations, we need to look at combining like terms. Okay? A term is a part of an expression separated by a plus or a minus sign. So x, 3t, okay? Like terms are two or more terms that have the same variable raised to the same exponent. The coefficient can be different. So you can have You can have 3x squared and 5x squared, and those are like terms because they have the same variable and the same exponent. The coefficient, the number before the variable, does not matter. It can be anything. Equivalent expressions are two expressions that are equal to each other. Okay? So kind of like equivalent fractions. They may be different fractions, but if you simplify them, they're equal to each other. Equivalent expressions, same thing. They may look different, but if you were to simplify them, they are equal. And simplifying is to perform all possible operations, including combining like terms. Simplifying is finding an answer. Okay? So, let's look at 14a minus 5a. We're going to identify the like terms first. And if you look here, coefficients different. We have 14 and 5. That is fine. Variables are the same, a and a. Awesome. They both don't show an exponent, so their exponents are the same. We are going to combine our coefficients and only our coefficients. The coefficients are the only thing that changes. 14 minus 5 is 9. So our answer is 9, and then we have an a. The variable and the exponent do not change ever. Okay? So the next one, we're going to identify like terms. Okay, so we look at these. We have 5t squared. So I'm going to go through and I'm going to see if there are any other terms with a variable t with a squared exponent. And it looks like there is right there. Okay, now that is the only other term. So then I'm going to go through and I have 7p. Now I'm going to go through and see if there's any other terms that have a p for a variable. Doesn't matter about the coefficient, but that still is raised to the same power. And there is right here. Now I'm going to combine the coefficients. I'm going to have 5 minus 2 and get 3. And I'm going to have 7 minus 3 and get 4. And it's minus because there's a minus in front of each one of those second terms. Now the 5 minus 2 went with the t squared, so the t squared stays the same. 7 minus 3 went with the p, so plus 4p, and p stays the same. Okay, now we're simplifying, but we have parentheses. If you have parentheses, you have to get rid of the parentheses first. How you do that in this case is you use the distributive property. The distributive property makes things easier to multiply and add or subtract. So what you do is you take the outside term and you multiply it by the first inside term. Then you take the outside term, multiply it by the second inside term. So you have 6 times 5 plus, we bring that plus sign down, 6 times n minus 2n. So that is the distributive property. Okay? Now, we need to combine like terms. But let's first do 6 times 5 and get 30. I was a little ahead of my time. So 6n and negative 2n are like terms because the coefficient's different, but the variable is the same and the exponent is the same. So we're going to combine the coefficients of 6 and 2 and get 4 because we're subtracting. Okay? And we have 30 plus 4n. Now this is going to be a thing where people are going to want to keep going and say that's 34n, but it is not. 30 is a constant. There is no variable. 4n is not a constant. It is a coefficient with a variable. So because both of your terms do not have an n, you have to stop there. Okay? and equivalent expressions at the beginning, this and this are equivalent expressions because we have simplified the first one down to 30 plus 4. Same exact thing as the first one. The first one's just big and confusing. Okay, solve x plus 3x equals 48. So we're going to first add like terms. X plus 3x. Okay, remember that the coefficient of x is always 1. X is the same as 1x. Okay, so when we add x and 3x, we get 4x. So we're going to combine the coefficients 1 and 3 and get 4, and then keep our variable attached. Then we have a coefficient with a variable, so we have to divide by the coefficient of 4 to get our x by itself. And 48 divided by 4 is 12. Okay? So your check it outs look a little bit easier than examples 3 and 4. So hopefully you can get those done fairly quickly on your own. They go along with example 2. Both of them go along with example 2. Okay, they're a little bit more trickier than example 1, but they seem to measure with example 2. So work on those and then get started on your lesson.